Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. As I had mentioned while doing the last video, I was talking about making a small presentation regarding position fixing tools and how you can do a simultaneous fix. Because fix is one of the most important feature in your chart work. End of the day, whatever you are doing in navigation, I'm or my ultimate aim is always to get my position. So which is a fix. So let us look into the different position fixing tools and let us see how we can do various methods of simultaneous fix. Now, before I start the actual methods of fixing, let us just quickly go through what is the meaning of fix. We have already talked about this. Fix is nothing but the true actual or the real position of a vessel. And since you are at sea, which is almost just like land also, both are same. So you are on the surface, which is a two-dimensional feature. So whenever I need a position based on two dimensions, I'll be needing at least minimum two position fixing tools. So minimum two. Now, what kind of tools do you come across? So either you will come across a position line or a position circle. Majority of the fixing tools are broadly categorized into a PL and a PC. So what do you mean by a PL? PL is nothing but a line on which, anywhere on which you can find your position. So you don't know the exact spot, but anywhere on the line. So it is also commonly called as LOP, line of positions. So what is the method to get a position line? The easiest method is a bearing. So when you measure a bearing from you to any object, you are basically measuring a position line. Similarly, what is a position circle? Position circle is nothing but any circle drawn, and you can find your vessel's position along the circumference of that circle. That is what is your position circle. How can you get a PC? You can get a PC by a simple range of any object, because all ranges are position circles. Now, we can use combinations, various combinations of this PC and a PL. So let us quickly look what all possibilities are there. Now, one of the simplest combination is having two position lines or two bearings, two position circles or two ranges. I mentioned terrestrial. Why? Because it could be a terrestrial object. Now, instead of these two, I can have one PL and a PC also. I can go ahead and get a fix with using two celestial PLs. So I'm using either the sun, moon, or star, taking a sight, and I can get a celestial PLs, also two PLs. I can use combination of PL or a PC with depth contours, sounding lines, or you can do spot soundings also. Now, there's a method called horizontal sextant angle. So that method will give me either a position line or a position circle, depending on the case. Vertical sextant angle is a method where I'll get a position circle, which means a range. I can use leading lights. So when I use leading lights, which is called transit bearing also, and in US they call it range lights also, I can get a position line. Now, different types of ranges can be calculated from a lighthouse. So they are geographical range, can be nominal range or present luminous range. So those methods also will give you a position circle. Okay. I can use arc of visibility. So arc of visibility could be two folds. One is a color change, and the other one could be obscured and visible sectors also. I'll be dealing with all, most of them, not all, most of them I'll show you. And of course, the last one is the most popular, giving you two latitudes and longitudes. I'm sorry, one latitude and one longitude, two of them together. So I can call each one of them as a position line also. Now, When you call fix, I can broadly categorize fix into two different categories. One is called simultaneous fix, and the other one is called running fix. So I'm going to deal only with the simultaneous part of it today. So let us see how I can get a simultaneous. What do you mean by simultaneous fix? When I get fixing tools at the same time, two or more fixing tools, then I call it simultaneous fix. So that means at that instant, where is my position? Okay, this could be just now the previous slide, which showed two PLs, two PCs, one PL PC, or various combination. All of them given at the same time can give you a fix. But important, you should plot only true courses and true bearings on your chart. So you should never plot any other bearings or courses like compass or gyro. Now, I'm going to show you the actual method how you can go about using the PLs and PCs. And I'll show you the same procedures and methods even on the chart also for a more realistic approach. So let us quickly look at two bearings and two ranges taken at the same time. So let us say I have two lighthouses. I have one bearing at from this brown, and then the other one is your violet color. So both of them, if they are taken the same, the point of intersection is called a fix. Then let us quickly see two ranges. And again, I got a fix. Please remember, I'm marking some small symbol of arrows at the edge of the PC and the PL. That is a symbol of a bearing and position circle. So please follow this. You'll have to draw a small arrow at the edge of the PC or the PL wherever you stop. Okay. So it depends on how much length you want to put it, but wherever you stop, you need to mark a small arrow. Now, whenever I have a PC involved in any question, you'll always see that a circle will try to intersect at two places when it intersects one more PC or one PL. Will try to intersect at two places, and that ambiguity has to be resolved in your question. So how can you do it? There could be a clue in your question. If not, then you'll have to use your common sense, looking at the question itself, seeing and sensing that whether this position could be right or wrong. So that you can make out when you're doing a question. So let me just quickly show you a possibility of ambiguity. You can see here. So one of them I marked with red, assuming that when I looked at the chart, I felt no, because of some depth or danger or land or whatever it is. This is not possible. So this you'll have to make out. Lat long is the most easiest one. I'm going to draw a latitude, then a longitude, and it's going to be a fix. Let us proceed with the next case where I'm giving you a PL and a PC. So let us say I have a PL and I have a PC. As I told you, please mark the arrows at the edge of both PL and PCs, so wherever it intersects. And here also you might get an ambiguity. As I told you, please resolve the ambiguity in the question. Now, I'm going to show you how to get a possible fix using PL and a depth contour. Contour is a line of equal sounding. So let us say this is a 50-meter depth contour. So you might have got this from your echo sounder or in olden days by hand-led lines, whatever it is. So this is also a fix. Now, let me show you a light color sector and a PC or a range. Let us use the color sectors. So I'm going to show you a light which has got sector of colors. Let us say this is your red sector and this is your green sector. And assume a vessel was going on a westerly course. So right now he'll be seeing the green light. And the moment he crosses this line, you will see the green will change to red. So this is how the question will be. He'll say at an instant, let us say 2100, the light changed from green to red. At the same time, if you are able to take a range from that lighthouse with a radar, so you might have a range also. So you can get a fix. Besides this, I can do the visible and obscured sector. The word visible and obscured is more of a physical obstruction. So I've given you two lighthouses. So if you see, because of the land with this blue color light, only this area could be visible, this sector could be visible. The other sector after that line could be obscured. Similarly, on this other light also, this could be visible sector, and this could be obscured. And same thing on the other side also. Let us say a vessel is doing a northwesterly course. Right now, this blue color light is visible for him, but the moment he crosses this line, it becomes obscured. So I get a PL at this case. Similarly, let us say one more vessel is going northeasterly. Right now, the top light of that island is obscured, but the moment it passes this, it becomes visible. So I can use this as a clue for position line also. I'm going to quickly show you how to obtain a range and a bearing from a radar, and then how do you go and plot on your chart. Let us just quickly look at one simple example. Okay. Uh, Radar bearing, please remember, bearing is always measured from the vessel to the object. So, but you're using radar to measure it. Only true bearing should be plotted. Okay. Once you get this bearing, when you go to your chart, you have to identify that object uh, positively, otherwise your fixing will be wrong. So you'll have to be careful on that. Okay. Same thing will happen to the range also. Ranges are also measured from the vessel to that object using a radar. But please remember, when you go to chart, you don't have your vessel there. So all you have is your object. So you'll be drawing the bearing also from the object in the reverse direction, and you'll be drawing the range also from the object in your chart. Why? Because you don't know where you are. So I'm just quickly showing you one example. Let us say this is a picture of a radar. My vessel is at the center. I want this tip of the land, and I'm using my EBL, and I found out answer was 237 degrees true. Okay, this one example. So let me just quickly show you how to find a range. I'll be using a VRM, variable range marker. So I want this tip of land's range. So I got a range and it is 4.4 nautical miles. So I could use these two. If by chance they were at the same time, I could have used it for a fix. At the same time, I can use a bearing also. At the same thing, I can use a bearing as well. Choice is mine. Now, let us try to make a fix from a single object. I'm assuming this chart, and I'll try to take a reading out of it, and I'll try to show you on a chart. But both the points are not the same. It's only depictive. Okay, I'm taking this. Let us say I want this tip of land. So I'm going to measure the bearing from me to him, and I'm going to measure the range also from me to him. Now, the same thing, when I go to the chart, I'm using a particular piece of a chart. I'm taking bill of Portland. So it doesn't matter. I'm just going to give you some imaginary values so that I can work on it. It doesn't matter. So this is bill of Portland. Let us say I got a bearing of 020 from my vessel, and I got a range of 5 nautical miles from my vessel. So I'm going to plot each one of them separately. Let us see the possibility of mistakes where you can do, so you should avoid it. Let us start with the bearing. Please remember, bearing is always taken from my vessel to the object. So I said 020, but I've drawn a line opposite because people can do this mistake. They can draw 020 from bill of Portland, and it is wrong. The bearings are always measured from me to that object. So when you plot it on the chart, you'll be drawing the exactly opposite 180 degrees. Okay. So don't consider the top red line. Your vessel is anywhere on the black color line, which is the opposite of 020. So this is wrong. Please don't do this mistake. It's a very, very common mistake beginners do. Please don't do it. So my vessel is anywhere on this line of 020. I don't know where. Now I'm going to try to look at range of 5 nautical miles. Let us see what is that. The range also was taken from radar, that is from me to him, but right now I don't know where I am. So I'll go to the bill of Portland, and I'm going to draw a circle of 5 nautical miles, taking bill of Portland as center. Okay, which means my vessel is anywhere on this circle. Now I need to mix both of them because I'm trying to talk about a simultaneous fix. I'm going to combine both the bearing and the range what we got now. Let us do that. So I have done both the range and the bearing at the same time now. So wherever it intersects, that becomes my fix. I'm sorry, that becomes my fix. So this is your actual position of your vessel. So this is how practically you take a radar range and bearing and transfer it to the chart. Whatever fixing methods I showed you now, I'm going to show you on a real chart picture so that it's more realistic. Let us look at two PLs. So I'm choosing these two starred lighthouses. One is your Catherine Point, another one is your Nap Tower. So I'm going to draw the bearing. Please remember, bearings are always taken from me to that object, but when you draw it, you'll have to draw on the reverse. Because you are anywhere on this two black lines, and if you sit on that black line, you will always find the bearing what you found out is correct. So please be careful on bearing part of it. Okay, don't draw in the opposite direction. So this is a fix. Your vessel could be in any direction. Lat long, I'm just showing you here, right hand bottom of the chart. Two lat longs is a fix. Okay, let us look at one PL and a PC. So this is a PL and this is a PC from the same Catherine Point, just like our radar range and bearing we saw. And this is your fix. Vessel could be traveling in any direction. Let us look at two position circles. This is Greenwich Buoy, and I'm looking at Beachy Head Lighthouse. So position circle, position circle. You can see I got ambiguity. And you can see I marked one with red. Why? Because obviously there is a traffic separation scheme implemented here. So you cannot be on this purple or violet color area. So you can be only on this. So you might be most probably traveling westerly. So now let us take a position line and spot sounding. Let us say Catherine Point, I took a bearing and a spot sounding gave me an answer as 19.2, 19.2. So here and here. So this is your fix. Let us look at a position line and a depth contour. So this is a position line, 30-meter depth contour. This is the fix. Position line with a 50-meter depth contour. This is a fix. Okay. Then I have from the Greenwich Buoy a PL and a PC. This is a PC and a PL. Obviously, I'm sailing in a northerly direction, sorry, easterly direction, eastbound. Let us look at transit PLs. I'm going to use one transit PL and one more PL. Let us see what is the transit. I'm using these two lighthouses for transit. So the transit bearing came as 128 degrees. Bearings measured from me to him. And same time, I got one more bearing from this lighthouse. So I have a fix. Okay. Let us look at a few last items here. I'm deliberately creating a light sector on this wolf rock. Okay, it is not shown, but I'm creating it. It is not depicted here. It will be there in your large scale charts. So the scale is not enough for me to show. So I'm creating it. So let me say that I have some sectors. This is the red sector. Let us say this is the green sector. And this is called white sector, even though it is kind of yellowish. It is white sector. Why? Because I cannot put a sector with white color on a white background. So usually it is depicted by this color. So let us say a vessel at 2000 was crossing and the color changed from green to white. So that means this is a PL for you. And 2100, let us say one more vessel was crossing here from green to red. So this is these are the ways where you can use all these different methods to put a to get a position fixing tool and then finally decide whether you can go ahead with a simultaneous fix. So that was a small presentation, mainly looking into various fixing tools and simultaneous fix. I will soon come with the other concept called running fix. Running fix has got more working to do. So I'll have to finish the concept or the basic concepts, and then we can go for a running fix. So I'll be coming soon with a running fix. Till then, please keep watching Jal Prayag, and until then, Vanakkam, Namaste, Namaskar.